Hello everyone, myself Dr. Kode Jaya Prakash. I'm working as Senior Assistant Professor in Department of Mechanical Engineering at VJEC. My specialization in PhD is on additive manufacturing. So I'm going to deal the subject on additive manufacturing. Okay, so what is the importance of additive manufacturing and how it is going to create a vital role in the present day scenario, that is industrial revolution 4.0, and what are the materials which are going to deal with, and what are the techniques, and how the additive manufacturing is going to be classified, we are going to see in detail. Now, coming to the case of what is additive manufacturing. So additive manufacturing in generic, it is also called as 3D printing. As a layman, it is also called as a 3D printing, but it is renamed by ASTM standards, American Society for Testing Materials, as additive manufacturing. So means that here the material is going to be laid this layer by layer. So since it is going to be done layer by layer, it is called as additive manufacturing, right? And the main source for this additive manufacturing is that we should have the CAD file, computer aided design file. So this CAD file can be done using any other softwares like AutoCAD, or you can use CATIA or SolidWorks, and different n number of softwares will be there. The most important thing is that the CAD file, whatever you are going to use, that has to be converted into .stl format. So this STL stands for standard triangular language. So where this entire CAD geometry is going to be encoded in the form of STL, and STL here is that every layer is going to be tiled by the series of triangles. So each triangle is going to give input to the concerned additive manufacturing machine how to lay up the surface geometry. So that is the reason why the acceptable format is the .stl format. So now this additive manufacturing, as you can see the terms, it can be also called as additive layer manufacturing and additive digital manufacturing, layer based manufacturing, or in other words called as a rapid technology, rapid prototyping, and digital fabrication. And as I told you, as a generic word, it's called as 3D printing. And here, as you can see, this originally called as 3D printing, based mostly it depends upon the CAD data. So where this layer by layer objects, layer by layer parts is going to be created using the CAD models. So as you can see this image of the CAD model, as you can see that for first portion, that a CAD model is going to be created, and then the layers are going to be sliced using the concerned slicer software, and then the material is going to be done layer by layer. Okay, and coming to the case of what are the advantages, mostly what are the advantages of this additive manufacturing. So we can able to replicate the parts, and we can able to work on complex geometry, and we are going to have the flexibility in doing that remodeling. Because if you go for subtractive manufacturing, it is quite difficult to doing this sort of replica sort of things, because it is mostly equipped with the costly, and this cost can be able to completely reduce by using additive manufacturing techniques. So whereas we can able to done with the repeated models. So when you compare to subtractive manufacturing, no expensive tooling is required, and also dimension accuracy is going to be maintained when you compare with the subtractive manufacturing, and also minimal waste. So when you go for subtractive manufacturing, a lot of scrap is going to be generated in the form of chips. If you go for CNC, if you go for drilling, so there are n number of operations, metal cutting operations are there. So those metal cutting operations are going to generate much amount of waste. But whereas here, when you come to the case of additive manufacturing, it is reduced to very minimal waste. Okay, and coming to the case of what are the limitations, because so for every procedure you are going to have some limitations, because each and every material and each and every process can't be sorted with all other materials. So material choice is a quite important task, especially non-weldable metals cannot be processed, and recent technology is going to be the work is going to be done here in the case of R&D point of view. So now non-weldable also slowly they're going to do R&D to going to happen in this additive manufacturing. And material properties. So parts made by this additive manufacturing is going to show anisotropy in the z-axis. So this is the most constrained thing when you take the case of this additive manufacturing. And coming to the case of subtractive manufacturing, additive manufacturing, mass production is not going to be suits for this additive manufacturing. Just like the subtractive manufacturing, you can able to create n number of parts. But whereas the additive manufacturing is a very slow process, the material is going to be done layer by layer. So because of this, only the reason it is a slow process, this is not going to suits to the mass production, right? So and as you can see this in this figure, this is the AM process chain. As you can see that step number 1, there's a modeling into the CAD model, and step number 2, that model has to be converted into .stl, and then after conversion into .stl, then the model is going to be sliced using the concerned slicer software, and then we need to define the build parameters. The fourth step is we need to define the build parameters like infill and how many number of layers are required, and what sort of support materials are required, and what sort of what is the material you are going to use, and what is the temperature, what is the extrusion temperature, what is the bed temperature. Everything you are supposed to be defined in the fourth step. And coming to the case of fifth step, the model is going to be built using this AM process. And step number 6, after doing the model, then after the schooling sometime, the model is going to be removed. And seventh step is that post processing, means that we need to remove the supports, and we need to remove the extensive supports, and we're going to remove the rafts, and that finally some post processing finishings is going to be done. And in the 8th step, the physical model is going to be prepared. So as you can see, these 8 steps, so this is the common AM process chain. So for every additive manufacturing process, this is the common AM process, right from material extrusion to till metals. So this is the standard procedure which we are supposed to maintain using this AM process chain. As you can see this, what are the steps I am going to explain. Just briefly I explain the steps: the concept layers of CAD, conversion to STL, and transfer to manipulation of STL file and machine setup, and followed by build and part removal and cleanup, post-processing of the part and application. So these are the steps, whatever I explained. So transfer to the machine and machine setup, and removal and cleanup, post-process and application, right? And coming to the case of how this additive manufacturing is going to be classified. So additive manufacturing is going to be classified into solid based and liquid based and powder based. Coming to the case of solid based, that comes under material extrusion. So in the case of material extrusion, the raw material is in the form of a wire or filament. So in that metal extrusion, the technique which comes under is fused deposition melting, means that raw material is in the form of a wire, and so that is going to be pulled using the extruder. So the extruder is going to heat that material with a certain melting point of the temperature, and then it is going to be deposited on the build plate. So it is fused and going to be deposited. That is what it is called as a fused deposition melting. And coming to the case of laminator object manufacturing, so this is the raw material is the form of sheets. So this sheets is going to be laid layer by layer, and then it is going to be cut by the CO2 lasers. And these two comes under solid based. And when you take the case of a powder based, so here the raw material is in the form of a powder. So selective laser sintering. Here the most raw material is in the form of a powder, and then it is going to be cured by the CO2 laser. So this CO2 laser is going to be a sinter and going to be cure and sinter, and so that the powder is going to be get solidified into layer by layer. But here the most of the materials is going to be used for based upon the polymer materials, polymer family materials. And coming to the case of the material deposition and selective laser melting, so these is going to be completely related to metals. Here the raw material is in the form of a powder, whereas SS and also cobalt based alloys, nickel based alloys, titanium alloys, all this comes under powder based. Okay, these are all treated with the metal based, and high amount of laser beams are going to be sinter the metallic powder. So complex structures can able to build using this sort of techniques. And when you go to the case of liquid based additive manufacturing, here raw material is in the form of a photopolymer liquid resin. So here polymerization. So this is the most important thing. So means that as a liquid photopolymer, when you're going to be exposed with UV light or X-rays or gamma rays, so then immediately it is the exothermic chain reaction is going to happen and it becomes solidified. So this is the technique which is going to be used for the liquid based additive manufacturing. So that comes under SLA, stereolithography and polyjet printing and direct light processing. So this is the brief about the overview of the classification of the AM process. Okay, and so this is how the EBM, electron beam additive manufacturing, wire arc additive manufacturing, this comes under DED process, that comes under direct energy deposition. So where the material is going to be instantly going to be deposited, and then the large amount of parts can be able to build using this sort of process. Okay, and these are the comes under the categories which comes under powder bed fusion. Mostly this metal 3D printing is going to be classified into two categories, that is powder bed fusion and direct energy deposition. This the main difference between powder bed fusion and direct energy deposition is that, so powder bed fusion, limited bed size, complex part can be able to build complex structures, which is not possible by using subtractive manufacturing. N number of complex profiles, complex contour profiles can be able to build using this powder bed fusion. But whereas when you take the case of DED process, when you get the case of the DED process, so it requires mostly not complex part cannot be built, and huge parts which requires a high build volume can be able to build using this process. So this is the main difference between powder bed fusion and DED process. And next, what are the techniques which comes under powder bed fusion? Selective laser sintering, already we discussed, and DMLS, direct metal laser sintering, selective laser melting, electron beam melting, that comes under powder bed fusion. And whereas when you take the case of DED process, it comes under electron beam additive manufacturing and wire arc additive manufacturing and wire laser additive manufacturing. This comes under DED process. Means that not complex part can't be built, but huge sort of build volumes can be able to done using this DED process. Right, so this is a classification, whatever I discussed previously, that metal extrusion, what is the source of the powder source, that is the thermal energy, power source, and powder bed fusion and high amount of laser beam and watt polymerization, you are going to use UV laser and material jetting. So there is a thermal energy or photo curing and binder jetting. Thermal energy and sheet lamination is going to be done with laser beam, and DED process comes under laser beam. And what are the primary technologies, and what is the brief description and end market application? Coming to the case of solid base, that comes under material extrusion and DED process. Mostly the solid base is going to be used for consumer applications, automotive and medical applications, as well as aerospace, military. And coming to the case of powder bed fusion and binder jetting, which comes under aerospace and consumer electronics, and liquid base, that comes under product designers and automotive and medical, and sheet metal, which comes under only for a decorative point of view or to show for the demo models. Mostly that is architecture and education, and living cells, that's a bio 3D printing. So where our gene cells are going to be taken and going to be imposed in the bio ink, and then it is going to be deposited as a layer by layer. That is called as bio 3D printing. And coming to the case of additive manufacturing in product development. So what is the main role in additive manufacturing and product development? What are the essential things which are required? The first thing is the computers. Mostly the computers are play a prominent role, because we are going to do the physical, we are going to do the objects which are in the physical objects, is going to play an important role to get it as output. So that all sort of CAD modeling we are going to do in the digital form. So that is the reason why this computers play an important role. And coming to the case of this, the computer should be having the high processing power, and initially it should have the high graphics capability, because this graphical user interface, and because all the machines should be fitted with good graphical interface, so that to operate and maintain. And coming to the case of machine control, so where this additive manufacturing machines can be controlled, suppose if you want to make a photocopy machine, or using developing on a thing. So for that, machine control is required, and networking and integration, because the files whatever we are going to use should be sent easily to the AM machine, and followed by the integration. And coming to the case of second step, that is CAD. So what are the essential things that are required doing this CAD modeling? So first is realism, means that whatever the CAD modeling we are going to do, it should be, so it will be in the form of a simulated models. So these simulated models are going to be modeled using the various CAD softwares, and then the usability and and user interface, where it is going to be used to work out on the different features. What are the features we are able to develop with the CAD models, and how to calculate the engineering content. Engineering content point of view means we should how the masses is going to be calculated and how much volume it is going to be there. And coming to the case of after that, then how well we can able to validate our CAD model using this FEA analysis. So next followed by the speed and accuracy. Accuracy means up to what sort of accuracy we can able to make that CAD model. So all this plays an important role, especially in the product development, especially when we're going to deal with the CAD modeling. And come to the case of lasers. So because the software should be well equipped, and also the systems should be very much compatibility to work out on the to work out and control the how the lasers are going to be strike on the surface of the build platform, and how it is going to be cured, and what is the curing stages, and everything we can able to monitor using this AM in product development. And coming to the case of materials, what are the common materials used in additive manufacturing? So mostly the metals, polymers, and also liquid resins. Coming to the case of polymers, thermoplastics, that is going to be used mostly by FDM, fused deposition molding, and solid to laser sintering. And thermosets, so that is in the form of a liquid resin that is going to be used by SLA, and powder based composites, that is a three-dimensional printing or binder jetting. It is also called as binder jetting. And in case of metals, you can use electron beam melting and select to laser sintering, and also sealant tapes and paper. So these are all comes under decorative purpose, are going to do for making of molds, that is used by laminate object manufacturing, and starch and sugar also, that is going to be used by the binder jetting. And coming to the case of this functional parts, that can be done with FDM and SLS and EBM, and non-functional parts you can able to do SLA and LOM, laminate object manufacturing. So this is the brief classification: plastics, metals, and others, and what the bioplastics and thermoplastics. And in case of metals, SS, titanium, aluminum, all different sort of metals is going to be chosen. Okay, so first one is nylon. This is going to be suits for FDM, fused deposition modeling, and it is also having the nylon is famous for this good durability, and it is going to have excellent strength to flexibility ratio. And also coming to the case of drawback, it is when you compare with this polymer family, the lifetime is quite less. So within 12 months, you need to complete this metal of nylon. Otherwise, it is going to lose its metal properties. And coming to the case of ABS, is a very tough material, and where the strength is required, you can able to utilize this ABS material. So ABS abbreviation stands for acronytrile butadiene styrene, and distinct properties. It is going to be cheap material for 3D printing, and this metal has a longer span, and this metal is not suitable especially for decorative purposes. Coming to the case of drawbacks, it requires heated bed while printing, because warping is the main issue. It's going to happen if a proper temperature is not maintained, and this type of filament is not biodegradable. So this is not biodegradable material, and hence for limited applications only it should be used. Whereas coming to the case of PLA, it is a completely biodegradable material. It is going to be made by using that food starch, sugarcane or corn starch, and PLA is easy to print since it is having low warping when you compare with ABS. It can also be printed on the cold surface. And what are the drawbacks? PLA materials are not very sturdy when you compare with ABS material, right? And coming to the case of PETG, so there's a polyethylene terephthalate is also one type of plastic, and this metal is highly durable, and impact. It is going to be this metal is very much impact resistant and recyclable. It can also be sterilized. And coming to the case of drawbacks, this material is going to be weakened by UV light. It is prone to scratching. So this is PETG and PET materials. And coming to the case of HIPS, high impact polyester, it is going to having the good machinability properties. It is a very smooth and lightweight, and it is inexpensive. And coming to the case of drawbacks, it produces strong fumes. So thus it is recommended to be used only in the ventilated area. And coming to the case of resin, this is going to be used by SLA, photopolymer liquid. So where this exothermic reaction is going to happen to going to be becomes a liquid metal into solid base. It can be used in many applications. It is having a low shrinkage, and this material is very rigid and delicate. And also coming to the case of drawbacks, it is expensive, and this type of filament also expires. And coming to case of gold and silver, this is going to be treated with DMLS, direct metal laser sintering, or SLM, selective laser melting. It is high electrical conductance. It is a heat proof, and drawbacks is that gold and silver are quite expensive, and lot of effort and time is required to get this powder to be sintered and going to be make as a component. And SS is a promising metal which is widely used, and the most only two possible techniques going to be used is DMLS or SLM, direct metal laser sintering or selective laser melting. SS can be heat treated in order to improve its high strength and hardness, and it performs very high in strength applications. And coming to the case of drawbacks, building time for 3D printing using these materials are much longer, and printing with stainless steel is expensive, and printing size is limited. And titanium. So titanium is a promising metal, is used for mostly for bio implants. Okay, mostly for implants, because this titanium is the only metal which is acceptable by your human body. So that is a biocompatible material. It is going to be treated with the EBM, electron beam melting. So mostly our hips and orthopedic implants, our dental implants are going to be made by using this titanium material. It provides greater complexity and resolution in design, and it offers industrial designers very precision in design. It has an average surface roughness, and drawbacks is that titanium is very expensive. And ceramics, it is high precision components is going to be used, especially if the parts should be with a glossy surface finish. It also has a resistance to acid, heat, and it also has a wide range of colors. And coming to the case of drawbacks of the ceramic requires a greater amount of temperature to melt, and it's not suitable for glazing and kilning process. So these are the mostly what are the metals going to be suits. And when you take the case of a rapid tooling, okay, so the next topic we are going to discuss is on rapid tooling. So rapid tooling is divided into two categories, that is a direct rapid tooling and indirect rapid tooling. Direct rapid tooling, here we are going to use the several aim techniques. Directly the parts are going to be done, and that is going to be used for making of the molds. And whereas when you go for indirect rapid tooling, master pattern is going to be created using this 3D printing, and then the mold creation is going to be done and followed by casting, because based upon the master pattern, several sorts of parts can be able to be done using this master pattern. So this is the main difference between direct rapid tooling and indirect rapid tooling. Okay, so mostly this coming to the case of rapid tooling versus conventional tooling. So this conventional tooling, time to market is we can able to get it, and cost, it is going to be when you take the case of a cost, rapid tooling methods often cost advantages. But whereas conventional tooling, especially when using steel molds, especially it involves higher costs. So whereas when you take the case of flexibility of the design, rapid tooling is having the prominent role, where you can able to work on the flexibility of the design. But whereas conventional tooling, once if you go for making of the parts, again coming back is a very time consuming, and also a much amount of labor we are supposed to be spent. Okay, and iterative development. So iterative development can be able to done only in the rapid tooling, but whereas conventional tooling, so such sort of iterations is going to be big constraints. And coming to the production volume. So this production volume, rapid tooling is not that much up to the mark, but whereas conventional tooling is going to be suited for mass production. Whereas when you take the case of applications of rapid tooling, so the mostly for prototyping and low volume of the parts and customized parts. The main theme of additive manufacturing is that customization means that if you go to subtractive manufacturing, you need to have, if you want to make any part, you need to have a mold and a die. But whereas in this additive manufacturing or this rapid prototyping, so based upon our own requirement and based upon the customer specific, we can able to build the parts. So this is the main specialty when you compare with the subtractive manufacturing and the additive manufacturing. And coming to the case of this other point that is called as bridge tooling, also full scale manufacturing can be able to be done, and spare parts and replacement tooling can be done, and tooling inserts and overmolding, jigs, fixtures and gauges. So these are the most important points applications when you take the case of a rapid tooling. And coming to the case of applications of 3D printing in aerospace and defense industry, the most important thing is that applications in aerospace is that communication. Because for anything, first is the communication is going to be done using the physical models. And then coming to the case of jigs and fixtures. So jigs and fixtures is that we are going to use the templates to build the parts. Okay, so the jigs and fixtures play a prominent role. And mounting brackets. Mounting brackets means that is after the parts are printed, after the parts has to be assembled, and what is the sequence of assembly? So that sequence of assembly is going to be done mostly on the mounting brackets. Okay, and high detail visual prototypes can be able to build using aerospace applications. And coming to the case of this automotive industry, rapid tooling, this rapid prototyping or additive manufacturing is going to be used for is going to control of the weight reduction. Because this weight, if you're going to control the weight reduction, fuel efficiency is going to be increased, and also streamlining or customization of your own interior aspects. So this customization of interior aspects and the decorations and how it looks like, especially can be how to improve this aesthetics point of view, can be able to be done using this additive manufacturing. And AR, VR, augmented reality and virtual reality can be able to improve here. And similarly, just like aerospace applications, jigs and fixtures are going to be used for making of these templates and molds and dies for your specific requirement, and custom interiors and aero design. Aero design is that especially to improve the speed. Okay, and coming to the case of for this biomedical applications, so customized requirement for my medical industry, because this human anatomy is going to be differ from each other. So when you go for this complex surgeries point of view, your human anatomy is going to be differ from others. So based upon your bones structures and based upon your body parts and based upon your anatomy, the parts are going to be calculated, and then the data is going to be taken from using the CT scans or MRI scans, and based upon that, that medical modeling software, they are going to use the medical modeling software to construct your parts. And then after the parts are going to be constructed, then it is going to be converted into HTL, and that HTL file is going to be used for this 3D printing of the components. So mostly this, what are the main applications of this medical modeling is that jaw reconstruction and hip replacements and knee replacements and breast reconstructions and facial reconstruction. Because if the patient is going to met with accident, so the jaw is completely broken, means that the one part of the profile is going to be processed in the medical modeling software using your CT scans, and then it is going to be reconstruct on the opposite side. Similarly, hip replacements and knee replacements, I think already it is very much familiar in nowadays. Based upon your specific bone anatomy, the knee replacement is going to be done. And coming to the case of breast reconstruction, if there is going to be, suppose if you're going to have the cancers, breast cancers, so most of the part is supposed to be removed. So this other side is going to be scanned using this scanning techniques, and then it is reconstructed using the concerned material, and then your skin is going to be grafted, and then it is implanted. And also for complicated procedures, because when you're going to work out with the patient point of view, the physical models are going to be prepared, and then it is going to be tested, and then it is going to be operated, and then only the concerned patient, the doctor or surgeon is going to be operate with the concerned patient. So these are the few examples of the medical modeling applications, and also for jewelry applications. So mostly for jewelry applications, as you can see, this investment casting plays an important role to cast these jewelry applications. Mostly the physical pattern is going to be done, and based upon the pattern, that pattern is going to be used for preparing of the molds, and these all the molds are going to assembled to one tree, and then this mostly the shell is going to be built and then followed by this casting, and then are going to take the products outside. So these are you can see this complex jewelry application, and n number of parts you can able to print using this SLA, using the Formlabs and SLA of the DWS. And SLA is these are the different companies of the concerned vendors of these 3D printing machines, but mostly used by the SLA or DLP. So DLP stands for Digital and Light Processing Techniques. So whereas this gold and silver is going to be done using this DMLS, sort of direct metal laser sintering. It's a very costly procedure. And coming to the case of coin industry. So this coin industry, whereas if you go to subtractive manufacturing, you are quite aware of the embossing operation. So that embossing structure is going to be developed, and then on the profile, and based upon that profile, then the embossing machine is going to be done embossing on that part. But here in the coin industry, what are the designs, flexible designs are going to be first done in the CAD modeling, and then it is going to be imported in the complex shapes, and that complex shapes of the dies can be able to be done. So using those dies, it is going to be assembled to the machine. We can able to build to the n number of parts. So this is application for coil industry, and also for tableware industry. Tableware industry is that especially for the tables and the sets of the plates and the sets and the different sorts of decorative purposes, this laminated object manufacturing is going to be used to make this sort of parts. Okay, this is for the table industry. Fine. These are the quite applications of the additive manufacturing. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.